Thank you. Thanks for the great introduction. And someone said on Slack yesterday that it feels like WWDC here, and indeed it does. The energy is really infectious, and I'm really excited. So I'm going to be talking about Codable Routing with Kitura today. A few slides about me. I've been with IBM for over a decade now. I work on the open source Swift Foundation libraries. Before this, I worked on Java standard libraries and the JIT compiler before that. I come from Bangalore in India, that's South India. Look at me, I'm a foodie. I like South Indian breakfast, so you ever visit Bangalore or any part of South India, you should try this. It's called idli. Please do try this. I really like it. There's hardly a day which passes by without eating this. I enjoy reading, and some of the best books that I have read are of Japanese origin. I've put them up here on the slide. This is my first time in Japan, and I'm really excited to be here. So today, we're going to talk a lot about JSON. Let's start with this simple JSON string that represents a commit. It's a very trivial JSON string, very unlike what you would work with in your real applications. So you have an author, you have a message, and you have the date, which corresponds to a commit. Now, the biggest challenge when you work with JSON is converting it to a language type, that's decoding, and converting a language type to JSON, which is encoding. Different languages do this in different ways. It's almost very challenging in most of the languages, apart from JavaScript, because JSON and JavaScript are related, and so it's really easy to interoperate between JSON and JavaScript, and that's by design, of course. So let's take an example of how JavaScript will decode and encode JSON. So it's as easy, the decoding is as easy as that. You just call JSON.parse, and then the variable to which the variable you initialize this with it actually inherits the shape of the JSON. And the encoding is, of course, very easy. Now, I understand that JavaScript is by design very close to JSON, and that is why it's very easy to decode and encode JSON in JavaScript. But this can be a benchmark for other languages. Of course, it will be a challenge, but it can be something, we can consider this as a benchmark. This expressibility, this conciseness, this readability can be a benchmark for other languages. Now, let's get started with talking about JSON and Swift. In simple words, you have that JSON there, and you have a struct below. Encoding is the process of converting that struct to that JSON, and decoding is the process of converting that JSON to the struct. And it should be type safe, which means the JSON string which has been encoded we should be able to decode that and come back to the same struct. So that's type safety in a simple sense. So before Swift 4, if you wanted to do this, if you wanted to decode using the JSON serialization class, this is what you would do. I don't expect you to read this. It's a lot of code for a very simple JSON snippet. Is it readable? I don't think it's readable. It is not really concise. And I think it is bug prone because you are using string constants. A small typo in one of the string constants which goes unnoticed can cause havoc. And typically when you're working with huge JSON strings. Many open source projects jumped into this arena of solving this problem in Swift. SwiftyJSON is what I personally like and what we personally like at IBM. And it's given us some relief, but still there is some clutter. I would say that the readability has improved, but still the use of string constants is there, something which should be avoided. And yet we are not close to our benchmark, that is JavaScript. So enter Swift 4 and things changed by leaps and bounds. Today with Swift 4, if you want to convert your Swift type to JSON, you can use the JSON encoder as long as your type conforms to encodable. If you want to do the reverse process, if you want to convert JSON to a Swift type, you can use the JSON decoder as long as your type conforms to decodable. Now, Codable is just a type alias for anything that conforms to both encodable and decodable. It's very simple. Now, what do you want? The next question is, what would you do to have a type of yours conform to encodable. You need not implement any property, need not implement any method. All you have to tell the compiler is, I am encodable. This type, struct commit, is encodable. You just have to put that encodable there, the colon encodable. That's it. Now with this, see how the encode routine looks. You just have to use the JSON encoder, configure a date encoding strategy. Of course, working with dates is very challenging. And then encoder.encode does all the magic for you. That's it. That's all that you need with Codable and the JSON encoder. Conforming to decodable is as easy as that. You just have to tell the compiler that your type is conforming to decodable. You need not implement anything. And then decoding is, again, a cakewalk. You just use the JSON decoder and make sure your date decoding strategy matches your date encoding strategy. And then decoder.decode does all the magic for you. Now this is just, I've just touched what Codable is. It's very complex, very deep. It's very powerful. So just to summarize, you can work with nested JSON. You can, so in this example, our property names were matching our key names, but there may be requirements where these are not matching. So you can provide that mapping. It's very easy and very much possible. You can work with arrays at different levels, at the root level or at any nested level inside. If you want to write custom encoding and decoding, say you want to cherry pick, you have a huge JSON string and you want to cherry pick a small part of it, that's also possible by writing custom encoders and decoders. You can flatten objects, basically take a set of fields and have an aggregation instead of those fields. And all this is type safe. So that's the coolest thing about Codable, JSON encoder and JSON decoder. This piece of work is really cool, really powerful. Now let's get to a very simple but a very significant and powerful application of Codable on server-side Swift. So I'm sure most of you here have heard about Kitura by now. Kitura is a web services framework built by IBM, but it's open source now. You can build end-to-end applications in Swift using Kitura. So the best thing about using Kitura is if you're developing your iOS app in Swift, you can also have the backend in Swift. And then what you get out of this is increased productivity because you're using the same language on both sides. You have a less likelihood of bugs, which come up because of type mismatches. And also, it's suitable for the cloud because Swift has a very low memory footprint. So tomorrow, we will be doing 2 workshops led by my colleague Taiji on building end-to-end apps with Kitura. So make sure you have enrolled for one of them. So just another schematic on how Kitura looks. So you have your client app. You may want to talk to a backend service built on Kitura. Let's make it a RESTful API, and you use JSON. You can develop apps in Kitura in Xcode, and you can debug them on Xcode. And once you have it ready, you're ready to deploy, you can do it in a Docker container, on the IBM cloud, or on any of the other public clouds. We support all of them. So let's take an example of a fictitious app and a fictitious backend. So the app is called Get Commits. It basically allows you to fetch all the commits from a certain repository. It also allows you to manually enter information of a commit and save it there on the backend. And it also allows you to get all the commits filtered by author name. So those are the endpoints listed there. There is a get commits, which gets all the commits. There is a post commit, which helps you post a commit. And there is a get commits by author name. Now we'll see how these can be implemented in Kitura. So we start with this simple struct definition that we have been using until now. So getting all the commits is, the code for that is this. you're telling the router, you're telling Kitura that when this endpoint is hit, the /commits endpoint is hit, you call that closure there. So the closure takes a request, that's you can say a processed HTTP request, and a response, which is again an abstraction for an HTTP response. And there is a pointer to the next middleware, which we'll ignore for now. Now, before sending the data to the client, you have to do that prepare JSON step. So we are just taking all the commits in the commit store and preparing JSON for it and then sending it. So that step over there is your encode step. So you are encoding and then sending it back to the client. Now let's see how posting a commit does. You get some commit information from the app, and you are supposed to decode that and store that commit in your commit store. So that's what the first 4-5 lines are doing, and that is, in a sense, decoding. So you're decoding JSON, and then you're running your business logic. Your business logic is nothing but just appending the commit to a commit store. And then you're sending an OK to the client. So the third one is filtering all commits by author name, and that author name is passed as a query parameter. So in this case, Kitura allows you to access the query parameter via request.query parameters, and then you filter based on the author name, and the resulting commits, you prepare the JSON for that and send it. So here there is a kind of a decoding step, and there is an encoding step. Now this is what we refer to as raw routing. It's you have a lot of control here. In raw routing, you are working directly with an HTTP request and an HTTP response. So let's see who is doing what when it comes to raw routing. So you have an HTTP request. Kitura processes that for you and prepares a router request. Then you decode the JSON. When I say you, the handler, you decode the JSON, the query parameters. You then run your business logic. Then you encode the result to JSON again. And Kitura processes the HTTP response for you, and then there is an HTTP response. Now just to see who's doing what again, this blue part is done by Kitura, and the 3 blocks in between are done in your handler. So essentially, in your handler, you're doing a decode step, the actual business logic, and then an encode step. Now what's flowing, let's see the data flow. Between Kitura and the handler, what's flowing is JSON. And between the 3 blocks in the handler, what's going into the business logic and coming out of the business logic are actually Swift types, in a sense. Now this is a very interesting point in the discussion, where if you think that these Swift types, if they are made codable, Kitura can actually take the responsibility of decoding and encoding JSON for you. So what happens as a result of having codable Swift types is this. You're reducing the handler to only the business logic, and you're actually working with Swift types. You are no longer working with JSON. You're no longer working with the router request and router response. Now let's re-implement those 3 APIs using Codable Routing. To start with, you make sure that the struct conforms to Codable. And this is how getting all the commits looks. The handler is taking an array, it's taking just a closure which takes an array of commits and a request error, returns nothing. So you're actually working with your types. You are not working with any other abstraction. You're working directly with your types. And it's concise. It's more readable than what we had for raw routing. Now let's see how the post commit looks. The handler actually takes a commit, which is the new commit. That's the first parameter, and then it takes the completion handler, and all you need to do is you just say commit store.append commit. So again, you are working directly with your types, not with JSON. We also allow you to process codable query parameters. All that you need to do is have a struct query which conforms to query params, make sure that you have, so your query, there may be multiple query parameters, so you should make sure that all of them are listed in that struct. If there is an optional, you just make it an optional. It's as simple as that. And then the handler actually takes a query instance, and it allows you to filter based on the values stored in that query instance. So the query instance is built based on the request which you receive. Now, this is something which we have recently released and which we will be demonstrating in tomorrow's workshops. Saving to a database has been always, it's always a challenge. It's always a lot of code. And if you wanted to save a commit, this is how your code would typically look. You would have a completion handler, then a database connection, and multiple nested handlers. Not really pleasurable. So introducing Swift-Kuery ORM. All that you need to do is make sure your codable type conforms to a type called model, and then you inherit a lot of code. So saving a commit looks as easy as that. You just say commit.save and pass your completion handler to it. So to know more about this, please attend tomorrow's workshops. We will be demonstrating this feature over there. So, so we kind of fixed the problem on the server side, the problem of encoding JSON and decoding JSON. But if you take a closer look at the client side, somewhere the problem exists on the client side as well. So somewhere in your view controller, you're probably converting a Swift type to JSON. Then through a networking package, you're talking to an API, and then the REST API sends you JSON. Somewhere you're decoding that JSON back to a Swift type. So we thought, why not apply the same thinking, the same codable thinking on the client side? And that's where we came up with something called KituraKit. It's available on CocoaPods. What it does is it encapsulates the process of encoding JSON, making a network call, and then decoding JSON. And it allows you to work directly with your codable Swift types. So just an example of how code looks. So this is saving a commit from your view controller. You just create a client from KituraKit, giving a base URL. And then in the save commit function, you say client.post. You give the endpoint there, and you pass the data as you're actually passing your type there, commit, which is a value of your type, your own type. So it's kind of the problem is kind of solved on both the client side and the server side. But one thing to remember here is it's preferable if you're using KituraKit. It's preferable to have your API also hosted. It should be a codable RESTful API. Otherwise, you need to take some extra care. So let's look at this end-to-end to make one last point. You have, so there are two worlds here. There's an iOS app and there is a Kitura app. I just want you to take a look at what is flowing between what components. So between the view controller and the KituraKit, there are Swift types. On the Kitura side, between Kitura and handler, again, there are Swift types flowing. The input to the handler is a Swift type. The output from a handler is typically a Swift type. And of course, between between the app and the server side, there is JSON flowing. Now, this creates the opportunity to actually share code between the client and the server. So if you make sure that your types conform to Codable, so your type definitions can actually be reused on both your, basically they can be shared between your client and the server. Now this may be a challenge today, but it's very much possible. If you want to get your hands dirty quickly, I would suggest you visit this particular URL there, github.com IBM food tracker backend. There are a set of instructions which can help you get started quickly. Thank you. It's been a pleasure talking to you. You can always visit our Slack. Please come onto our Slack, swift@ibmslack.mybluemix.net. For more information on Kitura, please visit kitura.io. And if you want to take a look at all the open source projects that we have, including Kitura, you can visit github.com/ibm-swift. And we hope to see you at the workshops tomorrow. Thank you.